Hello. Good afternoon, everyone. We're so excited to be here today. We know you have a choice of sessions, so thank you for choosing us and being here today with us. I am James, and I work on Android Studio. And here with me today is Jerome. He's the tech lead for the build system in Android Studio. So we're here today to talk about one of our favorite topics, which is how to speed up your Android Gradle builds. Now, slow build speed is a huge productivity buster. It's kind of like driving down the road and constantly hitting speed bumps after speed bumps. We've heard you loud and clear that build speed is critical to your productivity. That's why we've been focused for the past several quarters on improving our build speed performance. Now, to give you some context on why we're so excited to talk about this subject today, over the past year, we've been hosting a series of developer build clinics. In these build clinics, we meet with developers one-on-one, and they would come to us and tell us about their build performance issues. Now, we would play doctor in these clinics, which is kind of fun. But the most surprising part of this, and this was surprising to us, is that more often than not, we would be able to speed up their development builds by 3x, 4x, sometimes even up to 10x by applying a simple set of tips. And that set of tips is what we will share with you today. Now, our talk today will be structured into 3 parts. First, I'm going to talk about the tips for improving your project's development builds. Second, Jerome is going to talk to you about how you can make the most out of the new Android Gradle plugin 3.0 that we just released yesterday. And finally, he will wrap up by talking about some tools and best practices on how to debug and profile your build performance issues. So now, let's talk about the tips for speeding up your builds. So what I'm going to show you is that I'm going to present these tips to you one at a time. And what I'm also going to do is that I'm also going to use the Santa Tracker project as an example to show you the impact of each of these tips. Now, I'm going to apply these tips one at a time, and we'll see how fast we can get the build to become at the end. OK? OK, before we start, though, I need to talk to you a little bit about the Santa Tracker project, because build performance is really dependent on the project's characteristics. So the Santa Tracker is organized into 9 different modules, including a where module. It has about 500 Java files. It's pretty resource-heavy, with thousands of XML files and 3,500 PNGs. It uses multi-decks, no annotation processors, and the final debug APK is about 60 megabytes, so it's fairly large. If you would like to explore more about this project, you can find it on Google's GitHub account. Now, for benchmarking of this project, I'm going to show you 3 sets of numbers focused on 3 build scenarios. The first one is simply a full build. It's just a clean assemble debug. The second one is an incremental build with a Java change. It's a one-line Java change in a method implementation. And the third one is an incremental build with a resource change. And it's a simple add or remove string resource. And we can measure the build times for each of these. Now, just remember, build times are highly dependent on your project's characteristics and your build environment. So you may get more or you may get less out of these tips. That is to say, actual results may vary. OK, so the first tip is to make sure you use the latest Android Gradle plugin. With each release, we make a lot of bug fixes and fix performance issues, as well as introduce new performance features. So you want to make sure you are able to leverage those. Now, there are a couple of things to note here. First one is that starting with the plugin 3.0, we are going to distribute the plugin through the new Google's Maven repository that we announced yesterday. So you need to add that Maven line at the top to get the new plugin. Second is that the plugin often require specific version of build tools as well as specific versions of Gradle itself. So the easiest way for you to do this is do the update in Android Studio, because it will figure out what it needs and make sure it's the right combination. And third, the 3.0 plugin is a bit of an exception because we introduced some breaking changes. So it might require a little bit more work on your part to update. We've published a migration guide, and you'll see the link at the end of the presentation. And this was the result that I got after switching the Santa Tracker project from the old 2.2 plugin to 3.0 Alpha 1. Now, you can see that immediately we shaved off 25% from the full build, 40% from the incremental Java change, and about 16% for a resource change. Not bad for updating to the latest plugin. Now, second tip is to avoid legacy multi-decks. Now, I think most of you know that if your app exceeds the 64K method reference limit, you will need to use multi-decks. But what you may not know is that if your min SDK version is lower than 21 and you use multi-decks, you will be using what's called legacy multi-decks, which is a lot slower to build. So you want to avoid that. Now, if you usually start your build in Android Studio by hitting the Run button, this doesn't really apply to you, because newer versions of Android Studio will automatically detect the API level of your connected device or emulator image and switch to native multi-decks if applicable. Now, but I also know a lot of you are in the habit of doing your builds from the command line. So if you want to continue to do that, you should define a new product flavor. Here, for example, I call it development, and simply set your min SDK version to something that's 21 or above. And on the command line, now you can call assemble development debug, and you will avoid legacy multi-decks. And then these are the results that I got. We shaved another 5 seconds off the full build, a whopping 8 seconds. That's more than 50% of what we had before. And then incremental build for resource change is about the same as you would expect. Now, the third tip here is that you should disable multi-APK generation for your development build. Now, you do this typically by using the split block in the DSL. Multi-APK allows you to define dimensions that you want to generate multiple SDKs upon. The idea here is that you can tell it to generate along dimensions like ABI or density, so that it generates these multiple APKs that are smaller in size. Now, small APKs are great for your release builds, but they aren't that important for your development builds. So if you turn it on for your development builds, you'll be wasting time packaging and creating these APKs that you're not using. Now, to disable multi-APK generation properly, you can't just disable it in the splits block, because that block is global to all your build variants. So one way you can do it properly is to define a property like here. Here, I've defined a property called devBuild. And I'm just going to pass that property to Gradle every time I do a development build. And if Gradle sees that property, it will set the splits.abi and .density enable to false. And the multi-APK generation will not happen. Now, if you're using Studio, you can also pass this flag through the compiler options under Preferences by adding -p devbuild in this case. With this flag, every time Studio does a build, it will also pass the same flag to Gradle, so multi-APK generation will not occur. And these are the numbers I got after disabling multi-APK. Again, some more improvements across the board. Now, tip 4 is to minimize the set of resources that you package in your development build. Now, by default, the build system will include the resources for all the languages and screen densities that your app and the libraries that your app uses define. So if your app supports many different languages or many different screen densities, then you're actually wasting a lot of time doing work for no reason. Because during development, you're only ever probably going to be using one set of those resources. Now, to do this, you should use the res configs keyword and specify the language and the screen density that you need for your development builds. And then you can see here on the full build, we shaved off another 6 seconds, 24% off the incremental build in Java change, and 21% for the incremental resource change case, continuing to make gains. Next up is disabling PNG crunching. Now, by default, AAPT will crunch your PNGs to reduce their size, yielding you a smaller APK. Again, that's a great thing for your release APKs, but not that important for your development builds. So to avoid PNG crunching, you can use the same property that we define and add the AAPT options and cruncher enable flag to disable it if Gradle sees that property defined. And again, on Gradle, whenever you do a development build, you can pass that property into Gradle to avoid PNG crunching. The other option to avoid PNG crunching is to convert all your PNGs into WebP. Now, WebP is up to 25% smaller, so you get a smaller APK to boot. Newer versions of Android Studio also supports conversion within the IDE, so you can easily convert your PNGs into WebP format. Now, the only thing that you need to be careful about is the OS requirements. If you're using OPEG WebPs, API level 15 and above will support them. But if you have alpha channels and support transparencies in your WebP, then you need API level 18 or above. So that is something to be mindful of. So these are the numbers that I got after disabling PNG crunching. So you can see we shaved off 9 seconds off the full build here, which is pretty substantial. But that's also because the Santa tracker has a ton of PNGs in them. So previously, we were spending a lot of time doing that. And for the other ones, they didn't really change that much. Now, here's the kicker. When I looked at the APK size with crunching and without crunching, turns out there was no difference. Turns out Santa Tracker was already using pretty optimal PNGs to begin with, and it was just doing PNG crunching for no reason. OK, tip 6 is to use Instant Run. So Instant Run was launched in Android Studio 2.0. Since then, we have spent a lot of time improving its reliability. The version of Instant Run that we are launching with 3.0 is massively different than 2.0. We have removed a lot of hacks that we made to work around platform limitations to make things more reliable. The trade-off is Instant Run will now only work on API level 21 or above. Now, that does not mean you can't have your app's min SDK version set to lower. It just means the device that you're running Instant App on needs to be 21 or above. We've also tweaked the UI. So instead of having a single Instant Run button, the button is now separated into a Run and an Apply Changes button. When you hit the Run button, we will try to do a code swap. And the app will always restart. When you click the Apply Changes, we will try to do a hot or warm swap first. And that would push changes directly into the live process. Now, one thing to note, though, is that when you use Instant Run, it makes your lives a little bit easier because we, again, automatically look at the target device, look at its API level, and look at the set of resources it needs, and automatically build the minimal thing that the target device requires. So even if you didn't define a separate product flavor, you would automatically get some of the optimizations. Now, and these are the numbers that I got after. Notice we actually regressed by 7 seconds for the full build. The reason for that is that in order for Instant Run to work, we have to do extra work to shard the APKs and to do bytecode manipulation to prepare your app for future hot, warm, and cold swaps. So that's where that 7 seconds came from. We're working to drive that number down. Now, hopefully, you'll see that for the incremental changes, we shaved off 3 seconds for each of those cases. Hopefully, after you do a few of the incremental changes, you would recoup the initial build slowdown. Now, tip 7 is a fun one. It's to avoid that you should avoid inadvertent changes to your project. Now, and the code shown here is an example of such. At first glance, it seems pretty reasonable. The code here is basically just using the current date time as the version code for your app, which is a reasonable thing to do because every time you build, you want to have a unique ID so that when your QA team logs a bug, they can tell you which build it was. Now, the reason why this is bad is because this would force your Android manifest to change at every build, even the ones that you're not distributing to anybody. Now, Santa Tracker didn't have this problem, but I simulated this by forcing a manifest change every time. And this was the result. So as you can see, if I had that code in my project, I would have added 3 seconds to my incremental Java build every time, and 3.6 seconds to my incremental resource change every time. That's huge. And that's time spent for no good reason. Now, in the previous example, you can easily fix this by again, conditioning the setting of the unique version code based on the property, the def build property that we were using earlier. So in this case, if that property is defined, then we set it to a static value. If not, we will generate a unique value. Now, having bad code in your build script is not the only way to get into trouble. I know a lot of you use Crashalytics, and it's a great product, so it must be safe, right? Well, that depends. Turns out, Crashalytics, by default, will always generate a unique build ID on every build. But they provide a flag for you to turn this off. So you need to be careful about setting this flag. You should set this flag in your debug builds or development builds. Always update build ID to false. They also supply a different flag to disable Crashalytics altogether. And you can consider using that as well. Now, tip 8 is that you should not use dynamic versions. Gradle provides a very convenient way for you to tell Gradle that, hey, I want to use the latest version of this library through this plus symbol here. Now, it's bad for a couple of reasons. From a performance perspective, that will make Gradle check for new versions of that library every 24 hours, causing your dependency resolution time to increase. Now, even if you are OK with that hit, it's still bad because it makes your build non-deterministic. You do a build today compared to a build 2 weeks from now, you might be building completely different things because the libraries have changed underneath of you. So please avoid doing this. Now, tip 9 is that you should be careful about the amount of memory you're giving to Gradle. In Android Studio, when you create a brand new project, by default, we will give Gradle 1.5 gigabytes of memory. That might be a good setting for your project, or it might be a bad setting for your project. We don't really know, because it really depends on the characteristics of your project. So you should tweak this setting to see what's optimal. Now, another thing I want to call out is that in our DSL, we have this DEX options, where we allow you to set the Java max heap size for the DEX process. This made a lot of sense when DEX was out of process. But since the plugin 2.1, Dex is now in process by default, so you should not really set this flag anymore. So if you have it, you can just delete it. Now, the last tip here is that you should enable the new Gradle cache. Now, if you were at the What's New for DevTools talk this morning, you might have heard Xavier talk about this. This is a new caching mechanism from Gradle, where you can cache all the task outputs from every task. Now, this is different from the build cache that we introduced in Android Studio 2.3, which only cached pre-indexed external libraries. Now, this cache uses the same up-to-date mechanism, but it doesn't only work for the last build, but it works for any previous build from any location, which means it would really speed up your build when you switch branches, and it will enable distributed caching. Now, because this is so new, we haven't fully taken advantage of it yet in Canary 1, but we're actively working on this in 3.0. So our advice to you is that you should set this to true now, turn it on, and through the next several canaries, previews, and eventually stable, you should see progressively improved performance. And these are the numbers that I got after turning on the build cache, even though we haven't fully taken advantage of it yet. So you can see the full build actually dropped down by 7 seconds, and it negated the regression that was introduced by Instant Run. And the incremental build actually got slightly slower. That's something that we're looking into. So here are the cumulative improvements after applying all these tips. The full build is now 3 times faster. The incremental Java build is 12 times faster. And the resource change is also 3 times faster. Thank you. Now, here is a summary of all the tips. I have also created a GitHub repo if you want to be able to reproduce some of these results and experiment with some of these tips yourselves. And that's it from me.
Thank you, James. All right, so up to now, you've seen a number of tricks and tips to help with the performance. Now, I would like to talk a little bit more about some more radical changes you can do with your build to leverage some of the new feature that comes with Gradle plugin 3.0. And in particular, I'd like to talk about the multi-module projects. So we've had multi-module projects for a long time, but we used to discourage it because we had, quite honestly, a lot of issues, both in Gradle and in the Android plugin, around scalability. As you had more and more modules, the thing was getting slower and slower. So we worked really hard with Gradle to fix this, and now we totally recommend you to go to the multi-module project if that makes sense for you. But what do you have to do? So if you remember, or if you have created projects with Android Studio from scratch, any project Studio created from templates is a multi-module project to start with. It just has one, but you can add it. It's ready to be multi-module. To do that, you just need to include a few more subfolders in your main settings.gradle. And then you can start moving code from, say, the app into the lib1 or the lib2. Obviously, this sounds very easy. Modularity is not easy, I can guarantee. It's going to be painful if you want to do this. Not painful, but it's going to be hard. And it's not something you should do over the weekend. It's going to take some time. However, we're going to see that it has a lot of improvements with it. So here we have an example of 3 modules. The app, which is importing the lib1, which itself is importing the lib2. As you can see, there's a straight dependency. We are using the compile configuration to define this. And as you do a code change before in 3.0, say you're doing some code change in lib2, you would start recompiling lib1 because, say, your code change may be like removing a public method. So, of course, you need to recompile whoever is using that particular lib2 to make sure that you are not using that method. But it will also retrigger the compilation of app. And that's because the compile dependency is transitive. That means that app, which depends on lib1, kind of transitively also depends on lib2, just because lib1 itself was importing lib2. And that's some of the things that are going to change in 3.0. Now, the first thing that Gradle is giving us for free is compilation avoidance. So you don't have to do anything. You're going to reap some of the benefits from it immediately. And what they do is that they came up with the notion of an ABI. An ABI is the application binary interface. In simple terms, it means basically your public methods and fields, anything that can be invoked outside of the module. So you can have an ABI change, or you can have a non-ABI change, depending on whether or not you're changing a public API. Okay? Now, a non-ABI change has no impact on consumers. If you're changing the implementation of a method, which is private, why should or even if it's public actually, if it's just the implementation of a method, none of the consumers are going to be impacted by this change of implementation, so you don't have to recompile them. However, obviously, if you're removing a public method or changing a public method signature, this is an ABI change. This will trigger consumer modules to be recompiled. Okay, so far it's pretty simple. So let's look how it looks. I have a non-ABI change, so something which is private to lib2 is being changed. Nothing is recompiled. Now I have an ABI change, and we are going back to the original case of pre-3.0 recompilation. I'm changing something which is visible in lib2. lib1, which is importing it directly, has to be recompiled. An app, which is importing it transitively, also has to be recompiled. And that's really very annoying, because why would you want to recompile app? From this diagram, it seems pretty obvious that app is not using lib2. But the fact is that because it's declared through this compiled configuration, Gradle does not know if app is using the ability to use the lib2 interface. Basically, the compile leak the implementation detail of lib1, which is the lib2, to the consumers of itself. That means that now app can see lib1 and lib2. And that's really, really something that needed to be changed. Now, let's have a look at how that really ripples into when you have a really big hairball of modules. Here we've got only 9 modules, that's 8 modules, that's pretty simple. But say you have 50 modules, and you have one leaf module at the very bottom, and you're making a non-ABI code change, so that's, has to be recompiled. That's pretty obvious, right? Now, let's switch to the ABI code change. Let's say that now we are changing a public API of that really leaf module. Of course, we're going to recompile it, and then we're going to recompile all the immediate users. But because they are transitively dependent on each other, well, you're going to recompile the other ones too. And then eventually, you're going to recompile the app. Now, if you've had 250 modules, you're going to recompile 250 modules. And that, when you've got an SDK, a common type of library, this will happen quite a bit. So basically, what Gradle realized is that compile is all wrong. And there was no distinction between, oh, I want to use this library as an implementation detail of my library, but by no means should you be using the API of this library, because you should only be using the API of my library, versus, oh yeah, not only am I using this API, but I'm offering its API as part of mine, as a composition, if you want. So say, for instance, you are a library and you're using Guava, you want to provide your API. It doesn't really mean that you want your users to use the Guava API through you, because that's really nasty when you think over time, right? What about if you want to remove Guava from your implementation detail because now you're using the new JDK collection classes and Guava is not useful anymore? Well, you can't, because you used in the past to provide Guava as a transitive dependency of your module, so therefore you can break your clients. People can start using Guava API through your module, and that's it. So really, this compile dependency was all wrong. And all consumers of a module consumes all of their transitive dependencies, which basically was yielding way too many details about how you are implemented. So they Gradle came up with a new way of declaring your dependencies. Compile is now deprecated, and it's replaced by 2 new configurations, either API or implementation. So as you can see here, I'm replacing what I used to declare X and Y with one declared as an implementation detail, that's implementation. So that means that I'm consuming lab X as an implementation detail, but none of my users will have access to its implementation, to its API. However, I'm also using lab Y, and I'm also offering its API as part of my API. I'm composing over that particular module. Okay, so this is strict distinction between the two. Now, API is basically the equivalent of the old compile. It's the easy way to go. If you were to do a search and replace by compile with API, it would just work. But we totally not recommend doing this because, again, you're going to leak all your dependencies, and that's a bad idea. Better would be to use implementation. Then you clearly say, I'm using an implementation details. As an implementation detail of my library, I'm using this module, and I am not going to leak it to my users. OK? Seems pretty easy. So in fact, you should probably just do a search and replace of all your compile, replace it with implementation. Your build might break because some users of your library somewhere was using actually a dependency you were leaking. The only thing that you would have to do is that they would have to directly also declare their dependency on whichever module they were actually using. So it's a little bit more work, but it shouldn't be too bad. Now let's look how it looks like. Again, if you do a non-ABI change, nothing happens. You're changing lib2, lib1 and app are not recompiled. No change here. But if you switch to the ABI change, this was what we used to have. Now, ABI, with an ABI change, app is not recompiled any longer. Only lib1 will be recompiled because lib2 is not visible to app. This may seem to be a very little small detail, but when you come back to the example I gave earlier, where you had this ABI code change at the leaf module, you remember? I was compiling, obviously, the module that changes. You're still going to recompile all the modules that import it directly, but it's going to stop right there. It's not going to recompile anything else. Now, here you can see I'm saving about 50% of recompilation. Not too bad, but if you have an application with 50, 200, or whatever number of modules, this can be substantial saving. Okay? So it adds up. You have compilation avoidance plus these API implementation configurations, you're going to get much faster builds. I want to talk about one last final note on modularity. When you have multiple modules, Gradle can build them in parallel. We've had issues where sometimes one task has to run before a number of other tasks waiting for it to finish can be running. When you do things in parallel, you don't have such issues anymore. So this is really a great advantage to use multi-core machines when you have multiple modules. Having multiple modules is a great workaround for the lack of some of the incremental tasks. As you may have heard by now, and it's something which is very important, Javac task, the task that compile your Java code into class files, is in theory incremental. However, as soon as you start using annotation processes, we have to turn off the incrementality because some annotation processes, they want to see the world. They want to see Dagger, they want to see all the injection points. Are they all satisfied? So even if you change only one class, you will have to recompile everything so that the annotation processes can be fed and react appropriately. Now, if you split this Javac task into multiple modules, none of them will be incremental, but because they will be much smaller, each of them, they're all going to be much faster. All right. We try in the Gradle plugin to provide some parallelism within a task, but that's difficult and it's limited. And you will never get as much parallelism as if you are using multi-module projects. Now, let's say you've been very good. You followed all of James' tips. You've tried to understand what's wrong. It's still slow. Right? So what is the next step for you to understand? What can you do to figure out why is my build slow? Now, one thing to realize is that slow builds are not normal. This is not a reality in which you should be living. Let me be very clear. A full build that takes 10 minutes is not normal. An incremental build that takes almost the same amount of time as a full build is even less normal. And finally, when you change nothing and you run the build again and it seems to rerun a number of tasks, but you don't know why, because you changed nothing, this is clearly not normal. So there are scenarios like these that you should be looking into and figuring out Do I really have to go through this? Maybe there are some stuff I can do to make things better for me. And we all know that the build is a tax. Nobody likes to pay taxes. So understanding the build is like paying taxes on taxes. I understand that. But you must understand at some level that you need to spend some time into it, to invest into understanding where is my build being spent, which task is taking time, so that you can eventually have a chance to improve it. But what can go wrong? Like we talked earlier, third-party plugins. You have to be very careful about the third-party plugins you're using. Some of them are very well written, some of them not so well. Incorrect code organization, that's particularly true, for instance, when you were coming from the Eclipse side of things a few years back, where all the source files were in the source directory, like AIDL, C++, and Java, they were all in the same folder. So if you change one, it would trigger all the tasks to rerun. Some people like to customize a lot their build system, and sometimes it goes really, really wild. And finally, some incorrect settings. But you need to understand and spend some time in the build system. And I know this is not something that you like to do, you're app developers, but as your project is growing, you must spend some time. Now, there are tools to help you so that you spend the minimum amount of time. But before we get into this, I forgot that slide. One of the things we repeatedly see over and over again with people who complain about their slow build is the do last. Do last is bad. Gradle cannot understand if your task is now incremental or not, because it doesn't know what you're doing in there. Do last is bad because most of the time the up-to-date checks will also fail because you're probably writing something somewhere and it's in the output directory of the particular task, or you're changing something after the task run. And so basically, again, Gradle is lost. So it will rerun your task every time. Avoid this type of things. And one way you can do that is by writing your own plugin. I know it sounds scary, but believe me, it's not that bad. You can write your own plugin. You can put it in the build source directory, which means that it will be available to all of your modules automatically. Remember to profile it. I profile my code every day, and I'm always surprised. And instead of using do last, try to write a custom task with proper inputs and outputs so that Gradle can cache it. Gradle can understand what would make that task up to date or not. Now, you still don't get it. I mean, it's still slow, and you've been spending time on this, and it's still slow. So what can you do? Next thing to do, run with a dry run. This will tell you how much time you're spending in the configuration. This should be a couple of seconds, 10 seconds at best, at maximum, if you really have a huge project. If you start spending way too much time there, there's something wrong. Some plugin somewhere is doing something wrong, and we need to understand what it is. And it's not ours. Then you should do a --info. --info is very useful. It will tell you what tasks are running and why. Again, you change none of your source code, you rerun a build, some tasks are running and you don't know why. The --info will tell you exactly why this process manifest task is running. That's because the main manifest has changed. Then you have to do some detective work to figure out who changed it, because obviously you didn't change it yourself, but at least it gives you a hint. Next one is the profile, a slightly more complicated tool that will give you the ability to look at all your tasks and see how much time you spent in each of them. This is very high level. This is very useful to figure out that maybe one task is dominating. Most of the time we've seen this. One task takes 90% of the time of your build. Find out what it is. What is it doing before you report. And then for the hardcore, there is the Gradle Profiler. It's a tool which is provided by Gradle, and it's great. It gives you the ability to profile and to benchmark. The profile is the most interesting one. You can actually generate a profiler information right from there, which you can use to file bug against us. All right? So if you think that you've done all your homework, your build is still slow, you don't get it, run the profiler, give us a your kit profile information, file a bug against us, and then we'll start looking into why is your build slow. Much better than just filing a bug saying, my build is slow, I don't know why, not giving a build.gradle, not giving us any information. This is not stuff we can act upon. With this, we can look into why your build is slow. Some resources This is what we've seen today, the Central Tracker project fork. Look at the migration guide to Android Studio. Optimize your build speed. Look into the Gradle. It's always like, when you receive a new JDK, you look at the new things in the JDK. When there is a new Gradle, you should look into what is the new things in there. There's always a bunch of useful utilities that you can use. Thank you very much.